Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia, Profesor Dr. Muhammad Roslan bin Sulaiman, Naib Chancellor Universiti Putra, Malaysia. Yang berbahagia, Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan. Yang berbahagia, Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan yang akan menyampaikan syarahan inaugural pada pagi ini. Pegawai-pegawai kanan Universiti Putra Malaysia, ahli pengurusan fakulti, tetamu-tetamu jemputan, rakan industri, para staf dan pelajar dan para penonton yang dikasihi sekalian. Selamat datang diucapkan kepada semua yang menonton syarahan inaugural oleh yang berbahagia Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan. Untuk makluman semua, syarahan inaugural ini diadakan secara dalam talian mengikut norma baharu dan dipancarkan secara langsung melalui Facebook UPM dan Facebook Fakulti Kejuruteraan. Para penonton dialu-alukan untuk menekan butang like dan share halaman-halaman Facebook tersebut. Mohon kerjasama untuk mengisi kehadiran yang pautannya dikongsikan melalui ruangan komen di Facebook untuk sijil penyertaan dan mata CPD bagi pekerja UPM. Seterusnya, bagi memohon keberkatan syarahan inaugural kita pada pagi ini, majlis mempersilakan Encik Safairus Saleh dari Jabatan Kejuruteraan Aero Angkasa, Fakulti Kejuruteraan, Universiti Putra Malaysia untuk memimpin doa.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Ar-Rahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim. غير المغضوب عليهم ولا الضالين. بسم الله الرحمن الرحيم. الحمد لله رب العالمين. حمدا يوافي نعمه ويكافئ مزيده. يا ربنا لك الحمد كما ينبغي لجلال وجهك وعظيم سلطانك. اللهم صل وسلم على سيدنا محمد صلاة تنجينا بها من جميع الأهوال والآفات وتقضي لنا بها من جميع الحاجات وتطهرنا بها من جميع السيئات وترفعنا بها عندك أعلى الدرجات وتبلغنا بها أقصى الغايات من جميع الخيرات في الحياة وبعد الممات وعلى آله وصحبه أجمعين. Ya Allah Al-Wajid, Ar-Rahman, Ar-Rahim, Asy-Syakur. Sesungguhnya kami memanjatkan kesyukuran di atas segala nikmat dan rahmat yang telah Engkau kurniakan kepada kami, kedua ibu bapa kami, ahli keluarga kami, sahabat handai kami, guru-guru kami, serta seluruh warga Universiti Putra Malaysia. Ya Allah Al-Mu'izz, Kau berikanlah kami kekhusyukan di majlis inaugural yang berbahagia Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan pada hari ini, supaya kami tergolong dalam kumpulan yang Kau muliakan, serta Kau muliakan juga semua yang terlibat dalam menjayakan majlis ini, Ya Allah. Ya Allah Al-Fattah Al-Wadud, kami memohon kepadamu, Ya Allah, supaya majlis inaugural yang berbahagia Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan ini Kau berikan kelancaran, dimudahkan dan di akhirnya beroleh kejayaan. Ya Allah Al-Basit, Kau buka luaskanlah pintu-pintu ilmu-Mu supaya dapat kami manfaatkan dalam ibadah pekerjaan kami sebagai sebahagian usaha kami meningkatkan kecemerlangan diri serta Universiti Putra Malaysia dengan kuasa-Mu Al-Khaliq. Ya Allah Al-Muqit, Kau bukakanlah jalan kejayaan serta kekuatan kepada kami dan generasi-generasi selepas kami untuk kami memartabatkan serta mencintai ilmu-Mu ya Allah. Ya Allah Al-Quddus, Kau sucikanlah serta Kau peliharalah hati-hati kami sepanjang ibadah pekerjaan kami di Universiti Putra Malaysia dan hidup seharian kami bersama keluarga, sahabat handai dan guru-guru kami supaya kami menjadi hamba yang Engkau redai. Ya Zal Jalali wal Ikram, tambahkanlah kepada kami kecintaan kepada segala kebaikan. Jadikanlah kami, guru-guru kami dan pemimpin-pemimpin kami terus berkhidmat dengan istiqamah untuk menabur bakti membangunkan ummah, masyarakat, bangsa dan agama. Ya Allah, ya Tuhan kami, jadikanlah negara kami sebuah negara yang mendapat limpah rahmat dan nikmah. Kekalkanlah keamanan dan kemakmuran sepanjang zaman. Rabbana zalamna anfusana wa lan taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Walhamdulillahi rabbil alamin.
Majlis merakamkan ucapan terima kasih di atas bacaan doa itu tadi. Para penonton yang dihormati sekalian, seterusnya, majlis dengan segala hormatnya mempersilakan Yang berbahagia Profesor Dr. Mohamed Roslan bin Sulaiman, Naib Chancellor Universiti Putra Malaysia untuk mempengerusikan syarahan inaugural ini dan seterusnya menjemput Yang berbahagia Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan untuk menyampaikan syarahan inaugural beliau. Majlis dengan segala hormatnya mempersilakan.
Terima kasih saudari pengacara majlis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dekan Fakulti Kejuruteraan. Yang berbahagia Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan yang akan menyampaikan sarahan beliau pada pagi ini. Pegawai-pegawai kanan Universiti Putra Malaysia, ahli pengurusan fakulti, tetamu-tetamu jemputan, rakan industri, staf dan pelajar yang saya hormati sekalian. Alhamdulillah, syukur kehadrat Allah kerana dengan limpah kurnianya kita masih lagi diberi peluang untuk bersama-sama bagi meneruskan usaha memartabatkan keserjanaan ilmu pada pagi ini. Izinkan saya untuk membacakan latar belakang Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan di dalam majlis yang gemilang ini. Mohamed Thariq bin Hameed Sultan dilahirkan pada 31 Mac 1977 di Kuala Lumpur. Anak kedua daripada 4 adik-beradik kepada pasangan Haji Hameed Sultan bin Muhammad Sulaiman dan Hajah Sufaidah binti Muhammad Musa ini telah mendapat pendidikan awal di Sekolah Rendah Kebangsaan Gombak 1 dan di Sekolah Rendah Kebangsaan Zon R4 Wangsa Maju. Beliau seterusnya menyambung persekolahan di peringkat menengah di Sekolah Menengah Wangsa Maju Seksyen 2 sehingga tamat persekolahan pada tahun 1994. Usai zaman persekolahan, beliau meneruskan pengajian di Institut Latihan Perindustrian Jalan Kuchai Lama, Kuala Lumpur dalam bidang pelukis plan seni bina pada tahun 1995. Selepas menamatkan pengajian di ILP pada tahun 1996, beliau memulakan pekerjaan di SSM Associate selaku pelukis plan seni bina. Pada tahun 1997, beliau meneruskan pengajian diploma secara separuh masa di UTM Space KL dalam bidang kejuruteraan mekanikal dan menamatkan pengajian bersama segulung diploma kejuruteraan mekanikal pada tahun 2001. Setelah menamatkan pengajian dalam bidang diploma, beliau dinaikkan pangkat menjadi penolong jurutera di syarikat yang sama. Selepas menamatkan pengajian diploma, beliau meneruskan pekerjaan selama setahun sebelum meneruskan pengajian di peringkat sarjana muda kejuruteraan mekanikal di UTHM pada tahun 2002 secara sepenuh masa. Pada tahun 2004, beliau telah menamatkan pengajian dan dikurniakan ijazah sarjana muda dalam bidang kejuruteraan mekanikal dan seterusnya bekerja sebagai jurutera di syarikat yang sama iaitu SSM Associates. Kerjaya akademik beliau bermula pada tahun 2005, iaitu apabila beliau dilantik sebagai tutor di Jabatan Kejuruteraan Aero Angkasa Fakulti Kejuruteraan Universiti Putra Malaysia. Laluan kerjaya ini telah membuka peluang untuk beliau menyambung pengajian di peringkat sarjana dalam bidang kejuruteraan aero angkasa dan menamatkan pengajian pada tahun 2007. Pencarian ilmu beliau diteruskan di University of Sheffield, United Kingdom selama 4 tahun dan beliau kembali ke tanah air dengan segulung ijazah Doktor Falsafah pada bulan Mac 2011. Sekembalinya ke UPM, beliau dilantik sebagai pensyarah kanan di Jabatan Kejuruteraan Aero Angkasa Fakulti Kejuruteraan. Pada September 2011, beliau telah dipinjamkan ke bahagian hubungan industri Kementerian Pengajian Tinggi. Pada Oktober 2013, iaitu setelah tamat tempoh peminjaman di KPT, beliau telah dilantik sebagai pengarah Aerospace Manufacturing Research Centre ataupun AMRC sehingga 14 Ogos 2017. Seterusnya beliau dilantik sebagai Ketua Makmal Teknologi Biocomposite Introp bermula dari 15 Ogos 2017 sehingga 31 Januari 2020. Terkini, beliau merupakan pengarah Pusat Penerbit Universiti Putra Malaysia bermula 1 Februari 2020. Sidang hadirin yang dirahmati sekalian, Profesor Insinyur Dr. Mohamed Thariq juga merupakan seorang jurutera profesional yang berdaftar di bawah Lembaga Jurutera Malaysia atau Board of Engineers Malaysia. Beliau juga merupakan teknologis profesional yang berdaftar di bawah Lembaga Jurutera Teknologi Malaysia dan merupakan jurutera bertauliah Chartered Engineer yang berdaftar dengan Institusi Jurutera Mechanical atau Institution of Mechanical Engineers United Kingdom. Beliau juga dilantik sebagai penasihat saintifik bebas kepada Aerospace Malaysia Innovation Centre yang berpusat di Cyberjaya, Selangor. Berbekalkan pengalaman lebih 16 tahun dalam bidang pengajaran dan penyelidikan, kepakaran penyelidikan beliau termasuklah hybrid composite, advanced material, structure health monitoring dan impact studies. Sehingga ke hari ini, beliau telah menerbitkan lebih 260 artikel jurnal dan menerbitkan 15 judul buku di peringkat antarabangsa selain menjadi penerima pelbagai anugerah dalam dan luar negara. Pada bulan Disember 2017, beliau telah dianugerah Leader in Innovation Fellowship oleh Royal Academy of Engineering, United Kingdom. Beliau juga merupakan setiausaha Persatuan Pemantauan Kesihatan Struktur Malaysia yang berpusat di Universiti Putra Malaysia, Serdang. Terkini, beliau berkhidmat sebagai penasihat di bahagian Teknikal Pendidikan Kejuruteraan, Institusi Jurutera Malaysia serta panel penilai untuk Majlis Akreditasi Kejuruteraan Malaysia dan Majlis Akreditasi Teknologi Kejuruteraan. Hadirin hadirat yang dihormati sekalian, Profesor Dr. Mohamed Thariq aktif dalam penglibatan dengan pihak industri antaranya Airbus, Malaysia Airlines Berhad dan Tanjung Motors. Beliau juga merupakan pegawai utama yang dirujuk bagi kerjasama antara UPM dan Proton. Beliau telah dilantik sebagai Fellow Bersekutu Kanan di Institut Perubahan Iklim, Universiti Kebangsaan Malaysia. Di peringkat antarabangsa, beliau telah dijemput sebagai pembentang dan penceramah utama dalam lebih 30 persidangan di seluruh dunia termasuk India, Morocco dan Jepun. Kepakaran beliau diiktiraf di peringkat antarabangsa sehingga membawa kepada pelantikan beliau sebagai Profesor Pelawat oleh Institut Pengajian Tinggi dan Penyelidikan Barat, India. Beliau juga dilantik sebagai panel penasihat antarabangsa di Universiti Kalasalingam, India. Secara kumulatif, beliau telah menerima grant pendidikan bernilai kira-kira 8.8 juta ringgit Malaysia dari dalam dan luar negara dan telah menjalankan konsultasi bernilai lebih daripada 2 juta ringgit Malaysia dalam bidang perundingan profesional. Beliau juga dilantik sebagai Ketua Konsultan Antarabangsa bagi projek eksperimental and computational analysis of composite structure oleh Pusat Penyelidikan Aero Angkasa Sudan yang bernilai ringgit Malaysia 60,000. Dalam bidang inovasi, beliau telah memfailkan hampir 11 paten dan kini beliau sedang dalam proses untuk mengkomersialkan dua produk utama beliau, iaitu Rotating Blade for Natural Fiber Extraction Machine dan Putra UAV bersama Inaugural UPM, di mana beliau diberi pembiayaan sejumlah RM30,000 Malaysia dan Yayasan Inovasi Malaysia, di mana beliau diberi pembiayaan sejumlah RM60,000 Malaysia. Pada bulan Mei 2021, beliau telah dilantik sebagai penerima serta Regional Professorial Chair bagi tahun akademik 2021-2022 dalam bidang teknologi dan inovasi pertanian. Pada tanggal 23 November 2021, beliau turut berjaya mendapatkan grant bernilai RM1 juta Malaysia dari program Pelan Jana Semula Ekonomi Negara atau Penjana Kementerian Pengajian Tinggi untuk Career Advancement Program, KPT CAP. Selain penulisan jurnal terindeks, beliau turut aktif dalam penulisan buku ilmiah yang mendukung peranan universiti sebagai menara ilmu. Buku terkini beliau adalah buku suntingan bertajuk Impak COVID-19 dan Prakarsa UPM, terbitan penerbit UPM. Buku ini menganalisis usaha dan inisiatif yang dijayakan oleh pihak UPM seperti pengurusan risiko, komunikasi krisis, pasukan bertindak kecemasan, pendigitalan dalam pembelajaran dan pengajaran, pengurusan kebajikan pelajar, inovasi, advokasi awam dan putra bakti. Apa yang jelas, usaha dan inisiatif ini bukan sahaja bermatlamatkan untuk mengekang penularan pandemik dalam kalangan warga UPM, tetapi memastikan kelangsungan dan keteguhan institusi dapat dilestarikan. Sekarang marilah kita mendengar syarahan inaugural oleh Profesor Insinyur Teknologis Dr. Mohamed Thariq Hameed Sultan yang bertajuk Putra Unmanned Aerial Vehicle atau Putra UAV from Agriculture Biomass to Biocomposite Flying Drone. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Terima kasih yang berusaha Puan Pengacara Majlis, Dr. Ain Umairah Mat Shah, dan yang berusaha Tuan Pembaca Doa, Encik Safairus Saleh. Izinkan saya untuk berucap dalam bahasa Inggeris untuk syarahan inaugural saya. Qala rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Yang berbahagia Profesor Dr. Muhammad Ruslan bin Sulaiman, Vice Chancellor of Universiti Putra Malaysia. Yang berbahagia Profesor Insinyur Dr. Muhammad Khairul Anwar Muhammad Arifin, Dean, Faculty of Engineering, Universiti Putra Malaysia, Deputy Deans, Heads of Department, my beloved, respected family, my respected mentors, fellow academics, colleagues, industry partners and collaborators, engineering accreditation evaluators, my beloved students and researchers, and all of you who are attending this lecture via Facebook live streaming today. Today marks the pinnacle of my career in Universiti Putra Malaysia, where I will be delivering my inaugural lecture entitled Putra Unmanned Aerial Vehicle Putra UAV from Agricultural Biomass to a Biocomposite Flying Drone. Let's get started. Before we proceed further, I would like to give you an overall view about what is biomass. Biomass can be defined as renewable material sourced from living organisms such as plants and animals, including microorganisms. Biomass is also known to be source of energy, which can be transformed into usable energy through direct and indirect means such as burning and processing into biofuel. Now let's look at what is agricultural biomass. Agricultural biomass can simply be defined as biomass produced from agricultural residues or waste. The potential of agricultural biomass is explored extensively in more critical fields, such as in the production of biocomposites, composites, and other advanced materials. Comparing both sources of agricultural biomass from plant and animals, the use of plants as natural fibers receive tremendous attention due to its availability and easier to be processed. To overcome the harmful effects of synthetic fibers, plant fibers are suggested as alternative reinforcement in composites. Plants undergoes extraction process to obtain its fibers. Some examples of fibers used in composites are napier, sisal, kenaf, bamboo, flax, jute, and oil palm. Green composite from these plant fibers offers various benefits, such as biodegradability, high strength to weight ratio, and reduced greenhouse effects. The development of green composites is also in line with the world agenda to promote environmentally friendly materials and reduce waste problems. Currently, there is an increasing number of applications on agricultural biomass as the main material in creating green composites and hence conserving the environment. Each of the agricultural biomass material used in this application has good mechanical strength and thermal stability. The addition of their capability as a renewable source leads to a decrease in price of raw materials significantly. This consequence has further supported the material to be used as cost-effective and sustainable products. Thus, it has drastically increased the amount of research related to natural composite products. Natural fibers has been used in diverse applications around the world, such as flax composite was used in manufacturing of boat or yacht to replace carbon fiber composites. Flax is very light yet rigid and very strong fiber. For the car door panel, kenaf is used because it is very fine and has very clear fibers compared to flax or hemp, which is very important for the purpose of achieving a high quality surface appearance. In food packaging, the oil palm empty fruit bunch, EFB, was seen as a potential to replace the plastic packaging. Plastic packaging could not biodegrade, thus producing tons of landfills every single year. Porsche has created a car bumper by using a flax and balsa wood composites. Flax fibers were mostly used on the front and rear, while balsa wood on the doors and rear wing. replacing the metal and plastic injection molded part of the material. Throughout this inaugural lecture, we will discuss on the preliminary studies conducted on various types of natural fiber composites, which lead to the development of biodegradable UAV from pineapple leaf fibers. From the previous studies, it was discovered that natural fibers are suitable in producing a sustainable product. It was also found that most agricultural waste could be used in composites, which guides to the discovery of pineapple leaf fibers. Pineapple leaf fibers are commonly thrown away as agricultural waste after every harvesting period. It was found that pineapple leaf fiber, also known as Puff, has an extremely good mechanical strength when compared to other natural fibers. Thus, this fiber was then used to develop the drone structure. Before discussing on the development of drone structure, let us have an overview on each research that has been conducted by researchers under my supervision for the past few years. The first study, entitled "The Use of Radiation on Oil Palm Empty Fruit Bunch EFB Composites," has been successfully conducted by Dr. Siti Madiha binti Muhammad Amir. By comparing the effects of radiation doses used, it was found that both hybrid composites showed the highest water-resistant, tensile, flexural, and compression properties at 50 kg radiation dose. At the end of this study, it was found that the hybrid composite, which uses EFB as its core and radiated at 50 kg, has the best mechanical properties, which can be further analyzed for impact properties. The next study, entitled "The Development of Aircraft Tray Table for Aerospace Application from Kenaf Penang Fiber Composites," has been successfully conducted by Dr. Tamil Molid. In Malaysia, Penang tree was normally planted as landscaping plant along the roadside. Meanwhile, Kenaf is a type of bast fiber with superior strength and toughness. It is also an economic crop grown in Malaysia. From the research, it was found that the hybridization of Penang fiber, Kenaf phenolic multi-wall carbon nanotube has a significant increase in its mechanical strength. The composite was used for fabrication of aircraft tray table. In the next study, similar prototype, which is the aircraft tray table, was fabricated using different natural fibers. The study conducted by Dr. Tabriz Khan was entitled "The Development of Aircraft Tray Table for Aerospace Application from Kenaf Jute Composites." In this study, the hybrid between Kenaf and jute was incorporated into a sandwich composite to produce a laminated composite material that provides good mechanical strength suitable for the aircraft tray table application. The prototype of aircraft tray table was then evaluated in a free fall testing. Dye penetrant test was used to observe the damage or cracks that had been appeared on the tray table prototype after the free fall test. The next study, entitled The Development of KNAF PLA Filament Composites for 3D Printed Ankle Foot Orthosis AFO, was conducted by Ms. Farah Shazwani binti Shahar, which currently waiting for her PhD viva. The glass transition temperature, known as TG, was obtained to get optimum temperature for the 3D printer built plate. The melting temperature, TM, determined the optimum temperature of the 3D printer's nozzle or extruder. Finally, the degradation temperature, TD, is to obtain the maximum temperature that the filament could withstand before it starts to degrade. Overall, study shows that there was an increment in the mechanical strength of the printed composites. The next study, conducted by Dr. Ain Umairah Matshah, was entitled Transforming Bamboo Fiber into Non-Structural Aircraft Interiors. In low-velocity impact testing, comparison between non-hybrid epoxy, bamboo, and hybrid epoxy, glass bamboo composites shows that the non-hybrid experience multiple cracking and breaking apart, while the hybrid composites only experience perforation and penetration. Overall, these three different types of composite experience different damage progression, and the increasing range of impact energy shown in the table proved that the ability of hybrid composite in resisting impact at higher levels compared to non-hybrid composites. The next study, entitled Sugar Palm Composites for Low Impact Resistant Application, was successfully conducted by Dr. Shafiqa Nur Azri Safri. The figure shows that the SEM micrograph of 4 different composites, which are the untreated sugar palm composite, benzoyl-treated sugar palm composites, untreated sugar palm glass hybrid composites, and treated sugar palm glass hybrid composites. The SEM shows that the treated fiber from benzoylation treatment, the sugar palm fiber becomes rougher and improve addition of the glass fiber to the matrix. Let us continue with the next study by Dr. Nur Shazlin Razali with title Flex Knaf Composites as Alternative Materials in Automotive and Aircraft Components. From the preliminary analysis, Flex Knaf was found to have the highest flexural modulus. Therefore, this sequence was selected to be hybrid with glass fiber for the next stage of analysis. For the Knaf Flex glass hybrid composite analysis, it was found that as the impact energy increased, the energy absorbed by the specimen also increased. It demonstrated that more damage occurred at higher impact energy. The next study, entitled The Potential of Knaf X-ray Film Composites in Body Armor Application, has been successfully conducted by Mr. Ahmad Mustafa. The composites with sandwich configuration was then tested with high velocity impact. It was seen that the developed hybrid composites demonstrated great anti-ballistic qualities. It was also discovered that bullets generally entered knauf fiber layers in front of the specimen and be bounced back or trapped in the X-ray film layer. These results suggested that X-ray films becoming the primary cause of the composite material impact resistant, while fibers such as knauf operated as the ceramic front of the multi-layered armor system. It was found that there were a lot of studies that has been conducted on natural fibers, but only small amount of study that has been conducted on pineapple leaf fiber, also known as puff. Why do we use puff? There are several reasons that has compelled us to conduct a study on puff composites. First reason is because there is a large plantation area within Malaysia that had planted pineapple. Therefore, there are a large amount of pineapple leaf waste produced after every pineapple harvesting season. This brings us to the second point, which is easily available. Abundant amount of pineapple leaf waste means an abundant amount of puff that can be extracted from the waste. Therefore, there will be a continuous supply for this kind of fiber. In addition, by extracting puff from the pineapple leaf waste, the amount of waste could be reduced significantly. It could help in preventing the creation of breeding nests for rodents or snakes. And the final reason is because there was very less amount of study conducted on puff. Pineapple plantation in Malaysia is located across the country. Figure on the left shows almost all the Malaysian states had grown this crop, where the top 3 states having the highest landfills are Johor, Sarawak and Pahang, as in the year 2018 according to Malaysian Pineapple Industry Board. In Malaysia, there are about 12 varieties of pineapple registered under plant variety listed by Department of Agriculture, Ministry of Agriculture and Food Industries, MAFI. The pineapple industry are expected to continue growing as it is one of the national agendas to continue support in the industry through 12 Malaysian Plan RMK 12. The project to solve the pineapple leaf waste issues began in Teluk Panglima Garang, Kuala Langat, Selangor. A community project entitled Development of Novel Pineapple Leaf Fiber Extraction Machine for Villages from Waste to Wealth in collaboration with the Universiti Community Transformation Center, UCTC, was conducted by a group of experts from academia led by myself. A grant worth Ringgit Malaysia 25,000 was obtained through UPM Knowledge Transfer Grant Scheme, KTGS, to support the project activities. The project was conducted in Kampung Batu 10, Teluk Panglima Garang, to help the communities in managing their agricultural waste issue from pineapple plantation. The project was ended successfully in 2019 after a year of research and development activities. The outcome of the project was a development of pineapple leaf fiber extractor machine and a bun, as shown in the figure. In April 2019, Universiti Putra Malaysia (UPM) and Kebun Batu 10 community together with Majlis Daerah Kuala Langat had organised a ceremony on Kuala Langat Pineapple Hub Development Program at NPKK Hall, Teluk Panglima Garang. This ceremony was launched by former Minister of Water, Land and Natural Resources YB Dr. Xavier Jayakumar. This ceremony was attended by former Vice Chancellor of UPM, Vice Chancellor of Universiti Tun Hussein On Malaysia UTHM, former Director of Institute of Tropical Forestry and Forest Product Introp, former Dean of the Faculty of Engineering UPM, and former Director of the University Community Transformation Center UCTC. The participation, the involvement between ministry and university show that they are playing important role in ensuring the positive development of the community socio-economic as well as building a better future. The pineapple industry can capitalize on the biocircular economy by tapping into the commercial viability of every part of the plant in order to achieve zero wastage in the sector. Currently, the industry focuses mainly on pineapple fruits and related byproducts. Other plants are tested or treated as waste. Further studies need to be carried out to uncover the hidden potential of other plant parts in order to promote sustainability in the long run. The harvesting of pineapple fruit usually takes around 12 months to 24 months depending on the variant. The problem arises when the pineapple leaf waste is not properly discarded, which cause problem to the environment such as air pollution due to burning and housing to dangerous and poisonous animal when it is dumped at the site. To solve the issues with pineapple leaf waste, the fiber extraction machine was developed. There are 6 values offered from this machine. First, the fiber produced is fine. Therefore, it does not need the combing process. Second, the machine is compact and mobile, which make it easy to transport and store. Third, the price is affordable because it is produced locally. Next, the machine uses only one-man operation concept because it is easy to use. The machine has a simple mechanism, thus the maintenance in future will not be an issue. Lastly, the fiber extraction process is fast, which takes only about 1 minute compared to the traditional method, which take almost 20 to 25 minutes for extracting the fiber for a single leaf. The design of the blade was patent filed in 2019 and 2020 with the file number as shown in the table. Now, I'm going to play the video on how the fiber is produced using pineapple extraction machine. The next video will be showing the overall project of the development of fiber extraction machine.
In 2018, there are about 2,000 hectares of plantation land for pineapple throughout Malaysia. Malaysia pineapple had a very high demand in domestic and overseas. This shows that there are abundance of pineapple through the year. However, the leaf of this crop will be thrown or burned down after each harvesting process to give room new pineapple plant to grow. Throughout research, studies show that fiber from the pineapple leaf are very strong and have a huge potential in textile, composite, and craft industry. This initiates the improvement of current pineapple extractor machine to have a better extraction quality and productivity efficiency, besides providing affordable and economic PALF extractor machine. To achieve the first objective are by increasing the surface contact between fiber and machine's roller. More contact region will improve the fiber's fines besides fasten up the extraction process. The machine have no complex mechanism which reduces greatly the fabrication cost and will have less maintenance costs in future. The impact of this improvement will help local farmers to gain secondary income, besides becoming a supplier for the potential industry market locally and internationally. By having active local fiber supplier, industries such as textile and composite are expected to grow rapidly.
The figure shows the process taken to produce the fiber from the pineapple leaf. The fresh leaf is collected from the site and directly feeds into the machine. The extracted fiber is what we call as pineapple leaf fiber, puff. The puff are later sun-dried and then it is ready to be used. This is the properties of pineapple leaf from Yankee pineapple variant. In the chemical analysis, through the Technical Association of Pulp and Paper Industry TAPI, shows the presence of cellulose, hemicellulose, and lignin. The chemical composition for cellulose, hemicellulose, and lignin are 47.74%, 15.98%, and 2.44% respectively. The elemental composition of the fiber was analyzed to energy dispersive X-ray spectroscopy, EDX. The result shows the presence of carbon, oxygen, and potassium in the fiber. The composition of carbon contained 43.84% in weightage and 53.56% in atomic. The oxygen contained 46.8% in weightage and 42.93% in atomic, and potassium 9.36% in weightage and 3.51% in atomic. Both chemical and elemental composition analysis test results were confirmed through attenuated total reflection ATR. The ATR identified molecular component and structure in the fiber by analytical technique. where the cellulose peak was detected at 3,307.15, the hemicellulose peak was detected at 2,849.30, and the lignin peak was detected at 1,244.79 and 1,431.18. Lastly, the thermal degradation temperature of this fiber is at 340 degrees Celsius, and the single fiber pull-out strength is at 420 megapascal. The figure shows the composite made up from pineapple leaf fibers extracted from the Yankee variant in Teluk Panglima Garang, with the addition of fiber in the epoxy composite with fiber in Y direction obtained the maximum bending stress, which increased by 34.83% compared to neat epoxy. It was also found that the composite with fiber in Y direction obtained higher bending strength compared to fiber aligned in the X direction by 180%. The compressive strength of Y direction showed 0.8% more than X direction. The strength of composite with fiber in Y direction can be further improved by hybrid with woven glass fiber. The bending strength of the hybrid glass pineapple glass GPG composite proved an increase of 128.5% compared to hybrid Y direction fiber composites. Pineapple composites and pineapple glass hybrid composites were evaluated in low velocity impact testing. The results show that the non-hybrid pineapple composite able to hold up to 2 joule of impact energy, and beyond this impact energy, the composite break. The hybrid pineapple glass composite shows superior impact resistance compared to non-hybrid due to the presence of woven glass fiber on the top and bottom part of the composite that helps in resisting the impact. The pineapple glass hybrid composite can withstand impact energy up to 9 joule compared to 2 joule for non-hybrid composites. Now, we will discuss on the development of Putra UAV. The current problem with the commercial drone is that it is non-biodegradable and drone frames are frequently damaged and need to be replaced. With that in mind, through the research, the results show that replacing the frames with natural fiber composites is made possible. There are 5 criteria that make the natural fiber composite possible. It is biodegradable, lighter, cost-effective, renewable material, and low electrical conductivity. Putra UAV is a biodegradable drone which is made from natural fiber. In detail, the whole structure of the drone consists of double deck that were made from 4 layers of pineapple fiber mat and epoxy asymmetric for each of the deck, 4 rotor blades, and a lithium battery. The drone dimension is 210 times 210 millimeters as shown. You can see here in the figure. The Putra UAV pattern is shown in the figure as well. The fabricated composite panel was cut using a laser cutting tool according to the given drone frame dimension. The laser cutting tool was used to cut the composite because of its high degree of accuracy and has a clean cut with good finishing. After this process, the composite frame needed to be assembled and equipped with drone software and wiring system to actually complete the functional drone as shown in the figure. Malaysia Unmanned Drone Activist Society, known as MUDAS, participated as a project collaborator in this process. MUDAS is a non-governmental organization which provides assistance and advising along this project. Now, allow me to play a recorded video showing the details of Putra UAV. I would like to bring your attention in this slide. I'll be showing you on the media visibility for Putra UAV. The project has attracted international and local media such as Thomson Reuters, Hindustan Times, TV9, TV3, Astro Awani, and many more. The table shows a list of awards gained for Putra UAV since 2019 to date. The project was recognized locally and internationally in innovation competition. The highest achievement for this year, we managed to get a gold medal with a special award in the 10th World Invention Creativity Olympic WICO 2021. We were also awarded with a special award and Jury's Choice Award in the 5th International Invention Innovation Competition in Canada, ICANN 2020 last year. This table shows the list of awards for pineapple fiber extraction machine. Early in this year, the project was awarded with gold and a special award from World Invention Intellectual Property Association, WIPA, in World Inventions Olympics WICO 2021. In the year 2020, the project managed to get 2 special awards presented by Manila Young Inventors Association and Toronto International Society of Innovation and Advanced Skills in International Invention Innovation Competition in Canada, ICANN 2020. As mentioned earlier, we had collaborated with MUDAS and also with AECA Solution for Putra UAV project. As for the MPIB, UTHM and Majlis Daerah Kuala Langat, it was for the development of the pineapple leaf extractor machine. In conclusion, the use of agricultural biomass, such as natural fibers, as a renewable and durable material for the manufacturing of composite material has been successfully reported. Low-cost natural fiber-based polymer manufactured from hemp and other natural fibers such as oil palm, flax, bamboo, sugar palm, and knaf are attractive in terms of global sustainability and are finding growing commercial use in a variety of applications. Researchers using natural fibers had led to the development of biocomposite drone Putra UAV using Puff. It has a double-deck structure, motor, blades, and battery. Instead of synthetic fiber, these drones are manufactured from biodegradable materials. Through the use of biocomposite drone technology patterns, it is envisaged that outside party can collaborate to produce larger biocomposite drones that can do more vital tasks such as agricultural monitoring and border surveillance. Further, biocomposite drones are also expected to fly more than 4 hours to fulfill a more challenging task. In a nutshell, it was seen that agricultural biomass-based material can offer unique research opportunities and promises in various fields. Before I end this inaugural lecture, I would like to acknowledge everyone, each and everyone who had provided support and encouragement throughout my research journey. I would also like to express my respect to my principal PhD supervisor and to my principal master supervisor for their continuous support, advice, and encouragement. I highly appreciate the continuous encouragement, invaluable suggestions, and contribution made by them throughout the journey in my research. Taking this great opportunity, I would like to extend and express my sincere love and appreciation towards my beloved mother, Hajah Sufaidah binti Muhammad Musa, beloved father, Haji Hameed Sultan bin Muhammad Sulaiman, beloved brothers and families and friends. I'm extending my heartfelt thanks to my postdoctoral staff, Dr. Hamdan, not forgetting Dr. Ain Umaira Matsha, Dr. Shafika Nur Azri Safri, who had demonstrated their effort in assisting me throughout the journey in establishing research since 2014 to date. Finally, I would like to acknowledge the Southeast Asian Regional Center for Graduate Study and Research in Agriculture, SIARCA, for appointing me as a recipient of the SIARCA Regional Professorial Chair for academic year 2021-2022 in the field of agricultural technology and innovation. And finally, let's finish up today's lecture with this inspiring quote. Innovation is more than having new ideas. It includes the process of successfully introducing them or making them happen in a new way. It turns ideas into useful, practicable, and commercial products or services. It's a quote by John Adair, writer on business leadership. Finally, I sincerely appreciate that I've given this opportunity to present my inaugural lecture in front of all of you. With that, thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Majlis merakamkan ucapan terima kasih di atas penyampaian syarahan inaugural oleh Yang Berbahagia Profesor Insinyur Teknologis Dr. Mohamed Thariq bin Haji Hameed Sultan. Sidang penonton yang dihormati sekalian, dengan ini maka berakhirlah sudah syarahan inaugural pada pagi ini. Sekali lagi majlis merakamkan ucapan terima kasih di atas kesudian anda semua yang mengikuti secara dalam talian. Terima kasih.